Hello, and welcome to the 1D4 podcast, where we roll a die and ramble on about whatever topic it lands on. My name is Andrew, and joining me is Arjo,
Hello.
Nick,
Hi.
and Robbie.
Heyo.
And today, we are going in on some science. We are going to be discussing the search for life, and specifically the relatively recent. It's been a couple weeks now since it's been announced.
I think a week.
A week.
Depending on when this is releasing, it could be.
Yeah.
True. It'll be like 4
Different
weeks
time.
from now.
It'll be a while. But the discovery of the phosphine gas on Venus, is that how it's pronounced? Phosphine? Phosphine. Yeah.
Mm-hmm.
Cool. So we've got our resident experts down below me. Nick and Robbie each have their own stuff to bring to the table. So if y'all want to flex on everybody with your knowledge real fast, that'd be great. Just tell the folks why we should listen to you.
Robbie?
I can start first since I have the less impressive of the two. I have a degree in biology with a minor in chemistry, and I have just taken a lot of courses over that. And aside from that, sci-fi and science and astronomy have also been topics I've looked into a lot at Big Ben. But Nick over there.
Yeah,
Who's the bigger expert?
I would definitely not say I'm an expert on specifically astrobiology, which is what this is about.
Okay, fine.
I've done several geographic job positions at NASA or on NASA missions, but I'm a big science nerd and took a lot of astronomy classes in college. Therefore, that makes me a qualified nerd.
And published author.
Would you consider yourself an astrogeologist, or is that too
I
far?
would be planetary geologist, and I would like to say yes because I've always wanted to be one. But
Okay.
I definitely know.
PBS once.
I definitely thought of you that way in my head. So
Yeah, I like to think of myself that way, but I definitely know there's a lot of scientists and researchers that have done a lot more than me, and they definitely deserve that title and not me. So
fair enough. All right, so now that we've established
drop this humility shit, Nick.
We've established some semblance of what's the word? Credibility.
Rapport.
We can now officially begin discussion on aliens. Aliens.
If you can't see, we're doing the History Channel.
Oh yeah.
Thing for our listening audience, if we ever have one.
Specifically, like I said, we're talking about the discovery on Venus of phosphine gas in the upper atmosphere, something like that. So
yes,
I've read a few things about it, but for anyone like myself, what exactly is phosphine gas? What makes it significant as opposed to all the other gases that are presumably in that atmosphere?
Robbie?
Well, so phosphine is a relatively simple gas. Like going back to your basic chemistry, phosphine is just pH 3, a single phosphorus, 3 hydrogen. So not all that complex. The reason it's important in this specific instance is that phosphine, as we know it here on Earth, is primarily derived from biological processes. Like it's possible for it to be created in other ways. Lightning strikes are a good example of how it can be fixed otherwise, but in large quantities, we don't know any way in which a rocky inner planet could actually derive a large amount of phosphine.
And it was discovered in a suitably large amount, correct?
Yes.
Definitely.
It was also discovered in wide parts of the upper atmosphere, specifically in the mid latitudes, both north and south. The paper talked about how the concentrations weren't high enough to be detectable in the equatorial region, which suggests whatever is the source of this phosphine gas is regional. And there's also enough of it to be constantly producing and outproducing its decay rate.
Because things like radiation would cause phosphine to break down. So if it was just some random event, for example, some massive thunderstorm, something like that, fixed a whole bunch of phosphine in at once, which unlikely, but technically possible, it would decay rapidly over a short period of time. So there's something there that is generating phosphine at a faster rate than its decaying is, or at the very least a matching rate.
In my 2-day crash course trying to read up on this shit, I read that one of the biggest sources on Earth that they found of phosphine right now is actually sewage. that sewage is giving off large amounts of phosphine gas. They think from microbes doing shit that, like, they said they don't even know what it is yet. But apparently, like, sewage sludge is giving off large amounts of phosphine.
I don't know about doing shit, but it might be eating shit. Like,
wow,
Probably more accurate.
I walked into that one. Yep.
you did.
Yeah, and you're absolutely right. Gut-based microbes are very well known for consuming strange things and producing other strange things. A good example here, if I might get very technical here, farts. So
he did promise he was going to bring up farts. All right.
So here's the thing. Hey, everyone knows you eat beans, you fart. But the science behind that's actually kind of fascinating because human beings, as we are, cannot normally digest beans, or rather the chemicals in beans. Instead, we have a specific type of extremophile. Basically, it's an organism that lives in extreme conditions. It's not a bacteria as you know. It's called archaea bacteria. It's entirely different. Don't worry about that. But it's able to digest this stuff for us, and in return, it produces methane gas. So we are not farting. It's the stuff that live inside us that are farting, which is kind of even weirder.
It's farting into us, and then
yeah.
we're farting out. But
but yeah. So and the thing is, they don't just eat it. They use this as their method of energy production. Like, we use oxygen as our primary means, but this is a chemosynthetic process. It uses these chemicals and methane and things like that in order to undergo its energetic processes, and that's just sort of fascinating.
Would call that the metabolic process, right?
Yes, the metabolic process, correct.
Yeah,
that's basically probably a similar process to what those microbes are going through in the raw sewage y'all were talking about.
Exactly.
Yeah, and what would make phosphine.
So yeah, this theoretical source of phosphine in Venus's upper atmosphere.
Question for Nick then.
Okay.
What are we positive that this gas that we discovered is phosphine? I read that they verified it with another satellite, but I don't understand the actual process that they use satellites to figure out what a gas is.
Right.
Like, so how does that work?
So they're using spectral banding. So they're taking an image of an object, usually that has a gaseous material component, so that light can pass through it. And when light passes through it, it's going to be blocked or absorbed by certain particles in this gas. And once it passes through and comes to the satellite's detector, you can see spikes in energy pickup or no energy at all, depending on what this satellite is looking at. If a satellite is only looking at infrared and you see no infrared, then you suspect whatever is coming in absorbed it, or it doesn't produce it, I should say. Gotcha. And for this phosphine, they saw dips in energy absorption lines where this phosphine gas absorbs energy wavelengths. Okay. And they confirmed this by 2 submillimeter.
This is going to be really stupid and reductionist, but I feel like I saw that in the Spider-Man PS4 game.
That might actually be possible. I can actually lead into this because I can't talk about how using telescopes to detect something from far away would work. However, infrared spectroscopy is something very commonly used in organic chemistry. Basically, as Nick said, certain molecules and certain atoms will absorb certain wavelengths, and based on a reflection of those back, you can sort of tell the concentration. In organic chemistry, you can tell the concentration of carbon, your nitrogen, and your fluorine in your oxygen, your hydrogen, all that sort of stuff. And based on that, tell the chemical composition of something to a degree, because no composition is like purely one substance or another. But it's basically that same principle applied in a different sort of route. So yeah, if you saw it in a Spider-Man game, it was probably the biological infrared spectroscopy portion of it.
Yeah.
And so this same process is used for water a lot, because water has a very unique signature in spectrometers that we use to detect water on other planets, and with either in their atmosphere or on their surface. So this phosphine, they are expecting a certain amount of light to return at this wavelength. They see a dip in that energy, and that's also where they're getting their concentration from, the supposed 20 parts per billion. So for every billion particles within a certain space, there's 20 phosphines.
And is that a surefire way to determine that it is phosphine causing this? There's nothing else?
Technically, no.
Okay. Yeah.
Technically, there can be other gases or other molecules within the atmosphere that could do this, but because they're seeing this unique quote unquote phosphine signature that isn't associated with another molecule that they know of that they see, then they're suspecting it's phosphine.
Okay, it's
And the
basically
big
like
thing-
they've eliminated all the other
right.
major
Right.
possibilities, and
It's like
left.
water has several dips at different wavelengths. Phosphine, I believe, only has the single dip in the wavelength, and they're not seeing any other molecules dips where it would be phosphines as well. So they've eliminated
example,
other ones.
Yeah, for example, something
Gotcha.
that you might be worried about is if it's a more complex molecule that might have the
Phosphine.
pH3 or
Yeah.
pH3 as part of it, you would
Mhm.
see not only the dip where we expect to see phosphine, but along other parts of the spectrum.
Right.
However, if you're only seeing that one, that means it's the isolated instance of just that pH3, just that phosphine.
Gotcha.
So then I would also then say another big thing is that the reproducibility of this detection. So we come back months down the road and make sure it's still there, type of thing. Because we've had other detection events in the past on Mars where there's been methane near the surface as well as in the atmosphere that wasn't reproducible. It was only there sometimes when we were looking. So this phosphine, as long as it's there and it keeps staying there, we can assume that this source is continually producing it.
That's a good bridge to the next topic of where it was discovered. So it was in Venus's upper atmosphere. Do you like if under the assumption that like they think it's a living organism or microorganism that's producing this phosphine, could it move and then they wouldn't be able to like do you get what I'm saying? Like if they go and check 2 months from now and it's not there, is that a surefire result that like, oh, it wasn't really what we thought it was? Or like
we wouldn't know.
because if it's floating around in the atmosphere
Yeah.
somewhere, like it could kind of go wherever.
And again, on the pessimistic route, even if it's not life that's creating it, we would have discovered an entirely new chemical process that we are not aware of that could produce it. For example, phosphine is actually producible in other parts of the solar system. Jupiter is a good example. Jupiter can produce phosphine. However, Jupiter does this with massive, like, planetary convection currents that are multiple times the size of the Earth. So the energy required to do this without life is ridiculous. Like lightning strikes or planetary level convection.
Yeah. What about lightning? Does Venus not have lightning storms or anything? Is that not a thing that could have made it?
I mean, it's not the same kind of lightning storm we would have, but the same basic principle is there. Molecules rubbing up against each other creates a charge, and so on and so forth.
But so
yeah. So it's still possible, but again, it's the quantity. Like the realistic possibility that there's just so much lightning in a concentrated area that was able to produce this over a period of time is close to zero.
Yeah.
Okay. And so that. Oh, Nick.
So I was just going to say that to further Arjo's to answer to Arjo's question, it doesn't really matter if we have to capture the exact microbe itself. If we go there, we find more of this phosphine. Just seeing it being produced continually is a good indicator that there is something there. We might not be lucky enough to capture the exact microbe or whatever particle it is itself. But the bigger question being if it's in the atmosphere or if it's maybe on the surface and this phosphine is filtering up towards the upper atmosphere.
Yeah, that's kind of what I was thinking, because Venus is historically known as a very unhospitable environment. To put it lightly.
Yeah.
And so the phosphine was discovered in the upper atmosphere. We're kind of indicating that whatever life, if there is something, would have to also be in the upper atmosphere. Is it possible there could be something living on the surface through that kind of hardcore condition that is there, or?
Here's the thing about Venus. So, as far as you're asking about the surface, technically possible. Like I mentioned extremophiles here on Earth before, like the farting bacteria in your gut. But we do have some more crazy things. For example, one of the more famous examples are the sulfur dioxide consuming chemosynthetic bacteria that live in deep ocean vents. These are basically just like these vents at the bottom of the ocean that are just like constantly spewing out these sulfur-rich chemicals. And this is so deep in the ocean that, of course, light can't reach. But these ecosystems thrive because these bacteria, which are basically the plants of this system, they're just the base producers, are able to convert this sulfur dioxide into an energy source. And they live at extreme pressure, extreme temperature. So this is the sort of thing that we could theoretically see on Venus. But the interesting part is, whereas that differs with the upper atmosphere of Venus isn't all that inhospitable, especially compared to the surface.
It's kind of nice, actually.
Okay.
Yeah. The location that they found it is, if I recall, 30 degrees Celsius, which is less than 100 degrees Fahrenheit. It's 0.85 bars, so right at about our atmospheric pressure that we're sitting at right now. So it's kind of nice, just chilling
the surface of Venus is like 50 atmospheres of pressure.
Correct.
And insanely hot from the greenhouse effect of having 96% carbon dioxide as your atmosphere.
Correct.
So I get like Robbie saying, it is possible though that there is something living there.
Right.
And I presume if there was something living on the surface of Venus, that would be something that we could very possibly have not seen yet at all, because we have such a hard time of getting down to Venus.
Or even envisioning what it could be, which is why life there is exciting, because it could show us what life could be instead of what we've just seen before.
Mm-hmm. True. Right.
Cool. So that brings me. So my big question out of all of this is, what it would mean if there's life on Venus. So I see 3 different scenarios where this could have happened. Right. Either life got to Venus from Earth, which seems unlikely, because that would be a crazy ass trip. That would be a weird road trip. Or they shared the life that's on Venus and the life that's on Earth shared a common source whenever our solar system was in formation, which would imply that at least microbial life was around that long ago, while our solar system was still forming, which seems crazy because that would have to be very tumultuous conditions for life to start under. Or it just developed independently from Earth, which raises a crap ton of questions, because we still don't know the source of life, and if it can be duplicated on another planet near us under completely different conditions, that would that help us get to an answer of the source of life?
Remember that Venus is not that different from Earth compared to the other planets in our solar system. And compared to all the other planets and all the other solar systems, Venus is pretty close to Earth in terms of conditions as well as formation. The 3 possibilities that you brought up are the likely ones. I would just answer the first one saying that having pieces from a planet hit another planet are actually pretty not common, but it's doable. We have
the life would have to survive from here to there.
That's the hardest part, but theoretically possible, because tardigrades, we know, are an organism that can do it by itself. There could be an organism.
Are there organisms that can survive a vacuum?
Oh, absolutely.
Like the vacuum of space?
They're complex organisms too. They're not just microbes.
Wow.
The water bear.
Okay.
Get any sample of water and you'll find a tardigrade or a water bear. They're these cute little organisms. They were actually an Ant-Man. When he shrunk down, they mentioned don't get eaten by the tardigrades or whatnot. Like in the Ant-Man movie they meant. But anyways, the cool thing with tardigrades is that when they find, they're not actually all that durable. But when they find that they're in an environment that they don't enjoy, they basically remove the 70% of the water in their body, turn into a rock, and then just sort of sit there until things get better. And they can survive some really, really weird things.
There's no way that's real. What?
That
sounds like some sci-fi bullshit. What?
Near absolute zero temperatures, ridiculously high temperatures. I'm talking nearly 200 degrees Celsius. It's radiation.
Higher than that, I'm pretty sure.
Oh yeah, ridiculous amount of radiation. The vacuum of space. And if you're wondering how long they could do this, a while back they were trying to do some tissue samples of a 120-year-old moth tissue sample. They put some water in it, and while they were looking at this 120-year-old moth tissue sample, they noticed some tardigrades waking up from the moth. Some 120 people.
So that makes me wonder. Was it a Soviet probe in the 80s that actually landed on Venus? Could something like that have hitched a ride and it wasn't entirely sanitized or something like that?
Oh, shit.
That gets into planetary protection, not planetary defense, which is protecting the planet from asteroids, but specifically planetary protection, which is protecting other planets from Earth and our germs.
Yeah. Okay. Yeah. But that is a possibility.
That's a really neat idea.
Okay. Yeah.
And actually, the Israeli lunar mission that just flew and unfortunately crashed into the surface of the moon had tardigrades on it, I believe. Or was it the Chinese one that had tardigrades on it? All I know is that some tardigrades are on the moon, and the U.S. planetary defense or planetary protection was not happy about it.
They're just chilling there on the moon.
Yeah, it's not a binding thing that everyone has to sanitize their their spacecraft or whatever they're sending to other planets to a certain degree, but the U.S. enforces themselves a lot on it.
Mm-hmm. Okay.
Would it be if there were tardigrade type things in our atmosphere, though? Could you really stop them from hitching a ride as the rocket goes up?
There's the fairing that surrounds the payload, and so you can sanitize the inside of the fairing and make sure that nothing gets inside. Supposedly, that's the hope, at least.
Yeah.
Interesting.
Okay. So that's. Did we want to explore the other two possibilities beyond it being derived from Earth?
Yeah.
Yes.
Yeah.
Okay. So the second theory Arjo was talking about, like that both of them are from the same source from somewhere else. It's a theory actually called panspermia. Basically, the idea that life.
What does it say that again?
Panspermia. That like all life or something like that. It's Latin, not my expertise there. But
Gotcha.
basically the idea is that life is seeded from throughout from Earth from an extraterrestrial source, like maybe some extraterrestrial virus or not virus. Viruses actually had to develop after cells were around, but that's a different topic. But
I mean, to be fair,
bacteria.
Viruses are the most alien thing to life.
They are pretty weird.
But yeah, viruses. Well, because viruses aren't a living thing. It's
right.
Exactly. Yeah, they're not composed of cells. They're not alive, and they need cells to work, so they would have had to come later. But yeah, some weird alien bacteria, like before bacteria were a thing, proto-archaea, something like that, maybe hitched a ride and landed on Earth from an early meteor strike or something like that. That's the theory. And if that's the case, potentially it could be the same sort of situation where one of these lands on Venus and results in this. So that would be that second theory there. Again, possible? Yes. Maybe. But the third theory is where things get really interesting.
Yeah. So the third theory being that right now, the only source of life that we know is on Earth. Earth being the only planet as part of hundreds of thousands of quadrillion planets in the in the universe. Mm-hmm. We don't know of any other ones, so therefore we can only affirmatively say that there's life in one place in the universe. If we find life on Venus that developed independently and started its own thing and it was completely separate, that changes the whole game of what it means to be life in the universe and what our estimations are for there being life in the universe, especially for the fact that it's next door. Two planets within the same solar system means that the possibilities are infinite. Like the number of civilizations are almost infinite.
It would drastically improve because it's a huge, minuscule chance that this would even occur right next door, and then it would just drastically improve the chance of finding it more.
The fact that if it both independently developed, that means that the likelihood of life developing on any given place is much, much higher than we had ever predicted before.
Mm-hmm. Right now we use what's called the Drake equation to kind of guesstimate how many other life forms, as well as you can change it to be, I want to look for civilizations that have radio technology. I want civilizations that have spacefaring technology, which we only know of one. That's us that does that. But the chances get smaller and smaller depending on how complex the life is. But right now, it's all the variables in it are just guess. But if we have hard numbers, we can extrapolate that Drake equation to guess the number of advanced civilizations, microbes on a certain planet and stuff like that. And it's mind-boggling to think at how much would change.
A lower bar of what's considered the Goldilocks zone, or the bar gets lowered for what could possibly support life if Venus is able to, right?
Mm-hmm. Right. But to be fair, Venus is in this quote unquote Goldilocks zone where water is in a liquid form surrounding its star.
At least the upper atmosphere
really?
of it. Well, the upper atmosphere of Venus, remember, it has those temperature ranges between 0 degrees Celsius and 100 degrees Celsius at one atmosphere, meaning that at that point, liquid water can exist.
Yes.
Is that something that Drake does the Drake equation account for it can work in the atmosphere but not on the surface kind of thing?
Well, the Drake equation looks at the planets orbiting a star and how many planets are within the temperature range of that star's thermal radiation, and if that thermal radiation is within limits of supporting water.
Okay.
Because so far as we know, life requires water. Again,
yeah.
So far as we know, we only have Earth to look at, which is the issue.
Yeah.
Would this life on Venus getting confirmed, that wouldn't refute that, right? Because Venus still has water in the atmosphere, or would it change that?
I believe it has some amounts.
It definitely has water. Mm-hmm. Where it is, I'm not 100% sure. I would assume the atmosphere and the highest quantity on Venus.
Yeah, because Venus's
Okay.
surface is way too hot for solid ice to form. So it would, or even liquid to form. So it would have had to evaporate up into the atmosphere at some point.
Yeah. To be fair, we
Okay.
found water on Mercury though, but we found it in like the northern polar craters that don't see the sun.
Yeah.
Because
Yeah,
Mercury is
yeah.
also very hot.
And
So-
also the coldest planet in the solar system.
Yeah. So if we're able to get a chance to study these microbes, and if I think the most plausible is the third theory that it was developed independently.
Mhm.
So if that's the one
Right.
that we're going with, and that's what happens, then is it possible to study the microbes or whatever organisms we find there to gain, like maybe they're early on in the process of being life, whatever that might look like? Will that help give us some understanding to us?
I
And
imagine
Earth life.
as soon as they were able to bring samples back to Earth, they'd be using it for weapons development and to try to find a cure for cancer. Like as soon as it landed, those two things would get research underway like immediately. And I'd be kind of curious,
As
like
if they aren't already in
Sure.
development.
But yes, it definitely would. I would let Robbie speak to that about what the implications could be for that. But
Okay. Yeah, on the process as far as evolutionary biology, we can get up to a point. We know, basically, there's some famous experiments done that basically try to replicate the environment of early Earth where we think life was created. Basically, based on the atmosphere, the acidity, ecology, stuff like that, and even like lightning strikes and stuff like that stimulated with electrodes. And with these experiments, we can generate base amino acids. Think of these as the building blocks of life. You need amino acids to build proteins, and you need proteins to build pretty much everything in a cell. So we can get to that point. The problem is we are not quite sure how to get from the amino acids
to
to
the
forming
proteins.
complex proteins to cells. We are missing that chunk. Think of it like the evolution's major missing link.
Mhm.
Like the start of evolution, if you will. So we don't know how to. So if we see that this is some new life developing on another planet, and if it's similar to ours in any way, that would give us really big insight on that. Now, as far as Arjo was talking about weapons development or anything like that, or even cancer stuff, I don't think there's anything that's going to be got from that.
You'd be surprised at the tenacity of the military people. They'll find something.
They'll find some way to weaponize minute amounts of phosphine gas in the atmosphere.
Something that we could produce very easily on
Exactly.
our own.
Yeah, but it'll be cooler because it's aliens.
Yeah,
I
it's
mean,
alien
okay, yes, they released some sort of alien sickness.
Yeah.
That nothing because it's entirely alien to us. No living thing on Earth has resistance to it. Apocalypse incoming. There you go.
That sounds like the bad ideas that would happen from having militarized science.
Uh-huh.
Okay, yeah, okay, there we go. See, that's how we end the world. We've solved the problem. Everyone, great job.
We can end 2020 sooner. Woo!
Woohoo! So that basically leads me to believe the only real use for this discovery then, like the
There's
only
more discoveries.
yeah, is just as a bridge to farther discoveries, whether that be in evolutionary biology, like you were saying, or just an easier ability when it comes to looking for life elsewhere, that kind of thing. So cool.
That sounds like
do
you're
you wanna
downplaying how
ask-
cool it is because it is super cool if there's
Yeah,
actually.
I know. Yeah, no.
I just want to stress that fact.
Yeah, can we just
It's-
nerd out over that fact? Can we just be appreciative of that?
Dope
in and of
as
itself?
hell.
Like,
But
I do want to ask before we move to the
chills.
next topic. Robbie made a big deal about the Fermi paradox, and I feel like this will be his
Oh,
last
yes.
chance to
Okay,
weave
so,
it in
yeah. So
the
basically
conversation.
so the Fermi paradox is basically a thought experiment, if you will, about the likeliness of life or advanced civilization in the galaxy. So I'm just going to talk about the Milky Way here. So just our galaxy that we're in. So the Milky Way has about 400 billion stars in it. Of those stars, about 20 billion are like our sun. So,
What, yellow giants, you mean, or
yeah, basically of approximately the same size.
Yeah. Are
Chemical
those also
composition.
non-binary star systems? Is that including binary star systems?
Non-binary.
Okay.
So about 20 billion in the Milky Way. Of those, about a fifth of them, so about 4 billion, have planets within, or rocky planets within what we would consider the habitable zone. So 5 billion or 4 billion planets. So if even 0.1% of any of those developed any form of life, that is 4 billion planets within the Milky Way that potentially have life. Now, the Milky Way is about 13 billion years old. Earth is only about 4 billion years old, which means there's about 9 billion years of unaccounted time in the Milky Way where life could have developed on any of the other 399,999,999. And over that course of that, any number of those types of life could have evolved into, for example, the Kardashev scale rates civilizations based on how much they can and use of their energy that they can use. Type 1 civilization is like something that can use its entire planet's energy. Type 2 could be something that like builds a Dyson sphere and uses everything the sun can. So those things would be noticeable to us, but we haven't noticed any of those. So of these 4 million possibilities of other life that could have existed for billions of years before us, we have found no evidence of. And that's the Fermi paradox. Why is it that we haven't found alien life? Because they've had so much more opportunity to create.
Because they're hiding invisibly at the edge of the galaxy, and they're called the Reapers, and they're going to come kill us all. Okay?
Actually,
simple.
Actually, you're not too far off from the major theory. The major theory of the Fermi paradox is called the Great Filter. It's the idea that at some point in any form of life, it may not even be a civilization, it may just be life itself, there is some sort of filter, some sort of event that for whatever reason, it is impossible or incredibly difficult for life to get beyond. We don't know what this filter is. And that if the Great Filter theory is true, that leaves two very scary possibilities for us. So possibility number 1 is we have not reached that filter yet. Whatever that filter is, humanity as it exists has not reached that filter, and we are barreling towards it. Number 2, we have somehow, by sheer luck, managed to bypass that. For example, one theory is that nuclear weaponry might be the Great Filter. Like civilizations get to a point where they develop nuclear weapons, and that inevitably leads them blowing up their planet or mass extinction, whatnot. So, if we manage to make it past that point, we might be alone in this galaxy. Like, life cannot come and join us. There is no more advanced life. We are it, which is terrifying in an existential sense.
Yeah,
because we might.
One of my favorite things with the Fermi paradox that I remember now from my classes is that each new challenge or like big event happening in the world that affects the whole world is the potential next filter. It's like climate change right now is potentially the great filter that other civilizations might have also gotten to the same point where they're using resources on their planet at an exponential rate that they're just destroying it and not making it usable anymore. So that's a fun thing. There's also just killing each other, like with nuclear weapons, like as Robbie mentioned.
So yeah, if you guys didn't want to sleep tonight, there you go.
We need Thanos to save us, is what you're saying.
I don't know.
From using up our resources, you mean?
Yeah.
Yeah, I'm sure that'll work.
I'm picking up what you're putting down, Nick.
Yes. No. Wait. No. Here's the thing. Maybe Galactus is the Great Filter. Maybe there's just some cosmic running around eating up planets, and that's where this
they
all
get
goes.
to. Yeah.
I would hope we would see Galactus. Like, if we can't see the other life, we would at least hopefully see Galactus.
I mean,
right?
maybe other life exists, but it just knows to keep quiet about it. And here we have, for like the last 40 something, or like nearly a century actually, just been beaming radio waves into space while everyone's just sitting there watching us do it.
They're
Like,
just
laughing,
like,
like,
why aren't they
lack
being
critical
quiet?
information.
Yeah, no.
But then there's also the question of, if there is other life, do we want to meet it? Because
True.
all of humanity's experience with civilizations meeting other civilizations is enslavement of one of those civilizations,
or death.
Yeah, or death. So
yeah.
And not just that, it's a matter of scale. For example, if we're talking about a civilization that somehow manages to reach us, they would be so far beyond us that, for example, if you're building a dam to like build up a river, do you go and evacuate every single ant colony that's in that way? Like, we are not malicious towards the ants. It literally does not occur to us to even think about the ants.
Yeah.
And that could be very much like it. Like, if anyone's read Hitchhiker's Guide to the Galaxy or listened to the radio program, it starts with an alien's Earth getting destroyed because an alien civilization wants to build an interstellar bypass. That is the beginning of it. Like, Earth gets blown up just from alien bureaucracy because they just want to build an interstellar bypass.
Yeah. Huh. So, Yeah, that
Yeah,
that's a
a
lot.
thing.
That's a
Yeah.
lot. Yeah. Where do we want to go? I think we should.
We can jump into the next one. Human expansion.
Yeah, I think that about covers most of the discovery itself, what it could mean, and what a lot of things like that are. Human expansion in the solar system and just in general, around elsewhere. Like where, like y'all were talking about the Goldilocks zone and how in the upper atmosphere in Venus that's reasonable.
Mhm.
Is it
Would it be reasonable for humans?
exactly like would it be reasonable to float there for a colony? Like, is that even possible? That kind of thing, or is it not really doable? I don't know.
No, it's definitely possible. Yeah, like you can have helium. There's several science fiction topics about this of having like helium cities or floating cities in the upper Venetian atmosphere.
Like any Star Wars fan, think your Cloud City type thing.
Right. Exactly. So it's definitely with our current technology, I'm sure if there was a direct and immediate need to do so, we could do it, I think.
Okay.
Do you think do you think we have the means of transporting the materials and setting up a means for us to actually build it? Like, I'm sure like we have all the tech that we would need to make the city like in a vacuum in a fucking Minecraft god mode, but like could we actually like get out there and put it together?
If you took the entire production efforts of the whole world to do it, sure, probably, yeah. I more so meant like with our current technology, we could probably do it, but that's not including the advancement that you'd probably get from this impending doom or need to go out. Because when people are about to die, that usually boosts their intelligence for creating stuff.
Say an asteroid's coming towards Earth and we don't have Bruce Willis and a team of oil drillers that we can train up to go send them there.
Yeah.
Like that's one of the big things about wanting to get off of Earth. Earth is just a single place. If Earth goes kaput, as far as we know, there goes life.
Yeah.
So we want to sort of spread out a bit.
And the important thing is making these other colonies or experiments sustainable without the need for Earth to be in existence. So that's a big part of wanting to go to Mars, for example, because Mars is a lot easier to extract resources from the surface than it would be from Venus. But the problem with Mars over Venus is the radiation. Venus's atmosphere can block the radiation a lot easier than the Martian atmosphere can, as well as the Martian magnetosphere. So, and you can get around that by like living in lava tubes and stuff, but I mean, I like the sound of living in lava tubes, but a lot of people might not.
Would doesn't water also work?
Yes,
I thought
water does block radiation, but again, that's just a problem of basically living in a water dome situation. So, and another issue with Mars that Nick hasn't got around to yet is Mars has much lower gravity than Earth does. So over generations, like on a biological aspect, you would actually see degradation of bone quality. For example, we even see that in astronauts that stay up in the International Space Station. Like we see muscle atrophying and we see bone degradation just from their brief stays up there. Like they're constantly working out just to keep up their muscle. Because the amount of force, like think about your weight at any given moment on Earth. Your body is supporting that at any given time. So suddenly take that away and you're not. But Venus is almost exactly the same size as Earth. Venus is 1G the gravity of Venus is 1G. Venus, like, really? I think during the Renaissance and stuff like that, Venus was called Earth's sister planet for a reason. Venus is the same size as Earth. It has the same gravity. So the thing that I would say to that is that the astronauts in the ISS have no quote-unquote gravity. True. They're in a microgravity environment. We don't know how humans would interact or survive on a lower gravity or higher gravity planet.
And
it could be possible that they just get used to it and that their bodies get used to it, or generations down the line, it's completely normal to them. You actually see that in iRobot, and the people from Mars coming to Earth and being like, "Oh God, I get so tired when I'm walking around here."
You see that in The Expanse too.
Yeah.
But is there no? Obviously, there's no physical way to make it. But is there a theoretical way to make something like gravity drives? That's what a lot of sci-fi uses. Just kind of hand wave this away. But is there no way to artificially create gravity? Well, like under whatever water dome city you want to make on Mars or whatever?
Yeah, you can make a spinning top city.
Centrifugal force. And you even see that as like in early science fiction with like 2001 Space Odyssey. Like the ship they have in that is spinning around, and basically they walk on the outside of a wheel. Basically, it's the centripetal force of that spinning wheel that's designed to mimic the like 9.82 meters per second, which is the acceleration of gravity here on Earth.
So there is no way to make artificial gravity. You would just have to use centrifugal force in the
As
city
far
as a replacement. Okay.
Unless we want to look into like harnessing the power of black holes and like making miniaturized gravity fields, I think we're going to stick with centripetal force for now.
That sounds not dangerous at all.
It's like a spinning wheel or a black hole with the mass of Earth.
Yeah.
How would spinning top city work? Because the centrifugal force would be pushing him out, but Mars would be pulling him down. So how would that work?
It would be angled probably. I don't know. I'm going to be
Ferris
honest with you.
Interesting.
Yeah.
Or we go with Venus that has our gravity already. Again, like Nick said, we don't know the long-term effects of increased or decreased gravity. We just know like microgravity in the ISS.
Yeah. Mm-hmm. And so we talked about like settling, exploring other planets and that kind of thing. And we briefly touched on the cost, like with the current, not cost, but resource cost. Mm-hmm. Like with the current ecosystem, sorry, not really ecosystem, but like the political climate of Earth being very divided and that kind of thing. And a lot of the issue of space travel being getting it to a point where the resources aren't so much of a drain, like getting out of the atmosphere, right? Like what I'm getting at is space elevator. That's not just theoretical, right? Like obviously it is just theoretical at this point. No one's built a space elevator.
Is it realistic?
But it is realistic. Is it?
I would say on other systems and bodies, absolutely. Like the moon, a lot easier to do it. On Earth, really hard and not worth it, in my opinion, from the little math that I've done
just
on it.
Because of the rotation causes too many issues, or
the whole thing is that it's the stress on the materials, because basically you're having, like, depending on what this space elevator is, like if it's attached to a space station or whatnot, the stress of basically having a rope and swinging a space station around the Earth, the amount of tension on that, we're not entirely sure we know any materials that we can readily create.
Can't spider silk do it?
No, actually.
I thought I read somewhere there was some special like spider silk that could.
Well, I mean, if I'm going to be the bug guy, which I kind of want to be the bug guy, I'm for the record, for our audience, I'm the bug guy.
Yep.
For example, like you had there are spider silks that are much stronger. For example, the golden orb weaver spider, really strong webbing. Like if you had a golden orb weaver spider weave a web where the each individual strands were like the thickness of a pencil, you can catch a plane in it. That's not an issue. But even then, we're talking about some ridiculous forces, and we're trying to figure out how to produce these materials in mass quantities. Like, we don't really have any easy way to produce large amounts of spider silk. We have two main ways. We can either farm spiders, which is difficult, because the thing is, with like silk, you can toss a bunch of silkworms into a vat of leaves, and then you'll get a bunch of silk cocoons. If you toss a bunch of spiders into a vat, you get one very fat spider.
Yeah. Okay.
I mean, Switzerland has come out with another way to do it. They inject goats with spider DNA, so they produce the proteins that use webbing with their milk. But even then, it's not as strong as normal spider silk, and you get spider goats.
Spider goats.
If we had Skitter, could we do it?
Yeah.
For all our worm fans, you know what we're talking about? Yes. But for everyone else, no.
Only worm fans.
Yeah. So, and then another issue too is air friction and air drag being a big hindrance of perpendicular force on the material, whatever it is that we're using. And Earth is large enough and has a big enough gravity well that to get the end point all the way outside, like where the ISS is right now, that's a lot of material.
Yeah.
Whereas you can do something like on the moon at a much lower investment and cost, and also have it be much more efficient.
So, but we would colonize the moon first, and then build a space elevator.
Actually,
but like that would only really work if the moon, like if we got enough materials and self-sufficiency on the moon that it could become the source of resources that we would use. Which Like I don't. What is the composition of the moon? Like if we mine the moon, would we get like?
The biggest thing that we get is helium-3, if I'm not mistaken. Helium-3 can be used to produce rocket fuel. So its biggest possibility is for refueling station.
But beyond that,
Okay.
moon
So we would
if we're
still
going
mine
like,
the moon,
if we're talking-
send
yeah.
the helium down to Earth again,
Mhm.
and then have Earth send
No,
resources back up.
No, what we're saying is we do it all on the moon, and then from
But, like if all the moon has is helium-3, like
You
what
mine it.
if you need steel
Oh, sure. So
to make
this
spaceships, like
and the current Moon to Mars plan that NASA has, it's the moon is you send drills to the moon, you send converters to the moon, you have the people on the moon or the robots on the moon mine and convert the helium-3 or whatever minerals they're going to use to create rocket fuel there at the moon, send it up to moon orbit, have whatever spaceships from Earth go to the moon orbit, pick up fuel, go where else they need to go.
basically we turn the moon
so
into a gas
it's
station.
a pit stop. Okay.
Right. That's the current plan.
Okay.
Sounds good. So I think the next thought then, what do we gain? What's the point other than running away from our possible
Galactus.
apocalypse scenario? What
Running
do
away
we
from our
gain
2020.
from extraplanetary colonization? Like, what we've talked about mining resources and things like that. Is it just more of what we have on Earth? Is there, I know obviously planets are composed of different things, but like Mars versus Venus, is there a big difference in what we could get? That kind of thing. I don't really know what the possibilities are. So what are they?
Robbie, go ahead.
I was gonna say, well, between Mars and Venus, you're gonna get a lot of different things. For example, Venus rains sulfuric acid, so we can get a lot of acids, different complex alcohols. Also over there, your ethanols, your propanols, that sort of
Nice.
thing. Also diamonds. You would actually be able to find diamonds more easily on Venus because of the way carbon formation it happens over there. Nick over here, I think Nick knows a lot more about Mars than I can, so he could probably explain some of the stuff that you can get there.
Not a lot.
Do it.
Yeah,
like more so to make it worth the cost. There's not going to be a lot of precious minerals that we've found so far. You can find water at the poles. You can find carbon monoxide at the poles. You can find carbon dioxide in frozen form at the poles. It's mostly rocks, which Mars rocks do sell well, I will say. I've bought some myself.
yeah.
But-
If I'm the bug guy, Nick's the rock guy, just for our audience sake.
Uh-huh.
I would argue that you're not going to other planets for the resources. Maybe, I mean, sulfuric acid from Venus is actually pretty good. You'd mostly be doing that with asteroids. That's where you would get. It's a
And
lot easier to get asteroids and asteroid material back to Earth.
And that's why Mars might be useful as a nice little pit stop on the way to the asteroid belt.
Right. And a nice
Okay.
base.
Because asteroids, as Nick can probably tell a lot more, are much better when it comes to getting resources.
Yeah. Asteroids are a lot denser and have a lot more metals and dense materials in it that are hidden away in the Earth's core that we have giant pit mines to excavate. But even then, the material in these pit mines is quote unquote by happen chance at the surface. That should be towards the core. And these asteroids are just those core components floating around in space.
Okay. So it's not worth it. Okay. Yeah.
Wait, go into detail about like we were, for the people listening, we were talking about this earlier. Go into detail about like what mining an asteroid would be like and what we would have to do with it.
Oh,
Because that's so cool to think about.
The current theoretical plan would be to go to an asteroid and somehow capture it with your spacecraft or push it towards the Earth, stopping it in the moon's orbit and having it orbit the moon and kind of mining it out there or breaking it down in its base components and then shipping that back to the Earth. You wouldn't want to put it in Earth around or put it into orbit around the Earth because people get really mad when there's giant rocks floating above their heads.
Again, Bruce Willis, Armageddon situation here.
Right. But if it's around the moon, no one really gives as much of a crap. So
The moon has enough craters. I mean, if something goes wrong, just another one.
yeah. Actually, one of the theories is to throw them at the moon and then just go down to the crater that it creates and get the base components that come out of that. Which also lets you study live meteor impacts with in situ data. So,
and you get a bit deeper into the moon too.
But yes. So to answer your question, Andrew, I am one of the people that thinks that it is very much worth it to have different colonies and scientific advancement.
That was gonna be my next. I was getting into it's not monetarily worth it,
right?
But when it comes to going to other planets, getting research, and then potentially leading to self-sustaining
Right.
On that area. I feel like that's definitely
Mhm.
The
Yeah.
issue with that would be though is like somebody's got to pay for
Sure.
creating it, and it's like you'd either have to convince governments or private interests that it is good for them to
Mhm.
invest in that,
Right.
which might be
And then I
hard.
would also say monetization can also be done through private tourism as well. Just saying. If people
True.
want to pay $5 million to go to Mars and it only costs $1 million
Yeah,
to do it,
send billionaires to Mars. That's our new
Yeah.
our
Tom
new
Cruise
rocket.
is going to space in 2021. So
right? Exactly.
got
So
that.
space tourism
Start-
is theoretically possible as one of the things.
Mhm.
The biggest
Send Oprah to the
issue,
moon, please.
yeah.
Oprah's next interview on the moon. That's how we get funding.
That'd be great.
The biggest problem though with sending people places is when we get outside of Earth's sphere of protection, specifically from the sun's radiation and protons that it's throwing at us constantly and the solar winds. We shrivel up and get cancer real fast out there,
Oh
unfortunately.
yeah, the cosmic rays.
Makes
yeah.
sense.
So
Yeah,
and even if we have shielding, it's still 6 months at minimum, usually, of atrophied muscles like Robbie was talking about, or also just people not killing each other on a giant road trip out to Mars when you're in the same small enclosed space.
I know my family wouldn't make it.
Yeah.
Small metal tube for two years, would it be? Or
It depends on.
I don't know.
It depends the
Speed.
relative distance between Earth and Mars at any given
Yeah.
point.
Yeah,
Just
usually
remember,
the
their
windows
orbits aren't exactly the same, so at any
Yeah.
given point, Earth and Mars can be much further away.
Yeah, usually it takes about 6 months as our current.
6 months. Okay.
Like 2
I-
years would be like the worst case scenario if like Earth and Mars are like opposite sides of the sun.
That sounds like the best time to send people.
I mean, it's all predictive. Like you have to do it knowing that Mars is
Yeah.
not going to be in the because remember, you're aiming for a moving target here. You're trying to launch a rocket ship at something that's not going to be where you're going at the time you get there.
Yeah.
But it's not there right now.
So, living on other planets, though, step to getting it to the point where it's sustainable, we need something like biodomes, oxygen. We've already touched on gravity and how it's not really, we're not going to get us on a big Ferris wheel on Mars, something
Not
like
not
that.
not with
So-
that attitude, Andrew.
Okay, fine. But like that kind of technology doesn't currently exist, as far as I'm aware. Like a effectively self-sustainable biodome, or
So Biosphere 2 in
Yeah.
Arizona, near Tucson, actually, is our first quote unquote attempt, like most successful attempt at creating this self-sustainable place.
Because we have
Okay.
nowhere else that's as desolate and life-threatening as Arizona.
As Arizona.
The
Yeah.
Sonora
Yeah,
Desert is
true.
beautiful. All right. Okay. Calm down. But the problem always comes up with replacing parts and like replacing the oxygen converter. That's the oxygen scrubs and finding things with that. Like we know how to make sustainable food. We know how to make sustainable water. We can convert carbon dioxide and scrub it and make oxygen. But that's when we start breaking down of like, okay, we need to find a new way to do this from where we're going to be. But we won't know how to do that until we start sending temporary colonists. That's the theory, at least. If you start sending temporary colonists and you start figuring it out while you're doing it, the progress is going to be a lot faster than if you're trying to make it at home. You know?
Because we have to replicate the same situation.
Right.
Okay.
Gotcha.
And as terrible as
like-
Arizona might be, it's not Mars.
It's like in Satisfactory when you're trying to make a second base that's really far away from your first one, and you need to make parts that can only be manufactured by the automated machines. And like you basically have to build a whole new base over there on your second base. You know
While
what I'm talking about?
complicated and not a lot of people can relate, he is technically correct.
Oh, that's all I wanted.
Technically correct.
We can get the base resources, but we need something to replace the machines that allow us to get those base resources
Fair.
as they do.
Yeah.
And we need to be able to ramp up production on wherever this is.
So we need 3D printers that can print 3D printers
with
that
material
can-
from the place. Yes, absolutely.
Yes.
Actually,
Yeah, that's what I've read. There's like for Martian colonization, there's like a thing I read about like 3D printers that go down, like make some thing and use some things from the place to
You're
make some more things.
Yeah, you're probably
And-
pulling both like the atmospheric gas
Yeah.
as well as bringing a little bit of stuff to mix together and
Yeah.
make cement. Yep.
Yeah, which is dope. Like
it-
just
I
the fact
imagine-
of machines that make more of themselves can't go
I mean,
wrong.
we need to be careful now because
I am currently replaying through Horizon Zero Dawn, so I know it can go wrong.
Oh yeah, that
full of it.
Horizon Zero Dawn
But-
is basically not quite as bad Grey Goo situation. For those that don't know, a Grey Goo situation is where someone builds nanobots that are able to disassemble other things to convert them into nanobots, but they don't know how to stop, so they convert everything into nanobots, and all that's left of the Earth is a giant undulating mass of Grey Goo, like trillions and trillions of nanobots.
I
Sounds like that.
imagine, speaking of like specific materials they would need, I imagine silicon would probably be something that would be very important to be able to either harvest or print at on location, right? Because
I mean-
silicon chips are so important to every
Yeah.
piece of technology we have.
If you're looking for the biggest source of silicon that isn't the Earth, Mars is your best bet.
Really?
Yeah.
Yeah.
That's good. So why have we not colonized Mars already?
Because we
don't-
have lots of silicon.
Yeah, basically, so far as most people on Earth are concerned, the resources we have here are enough for our day-to-day stuff. So no one wants to put those day-to-day stuff resources towards going somewhere else where we could get more of those same resources here.
But I need more Mars rocks in my life, so therefore we can go get more Mars rocks and then.
And
And I want to
Yeah.
find Mars bugs if they exist.
There you go.
Yeah,
See?
there you go.
Why can't everyone just be like us?
I know, right? We're just together.
If only.
I know.
Wait, that'd be terrible.
I know. I think that'd be great.
Uh-huh. All right, so we've kind of already touched on like getting there, that kind of thing. I got to that earlier. What would do you think would be the biggest push to leaving Earth?
Well, if Earth was
Probably running out of resources, although
running
it
out of
could be war.
resources, if
Well,
Earth
because I was
got
going to say we are
destroyed-
running out of resources.
Oh yeah.
It's like
It's
Climate
like-
climate change might also be the biggest.
It's like the
push, climate
situation
change.
of what they say, like a frog in a boiling pot. And,
Mhm.
If you do it slowly enough, the frog will never notice up until it's too late.
yeah.
That sort of situation. Another situation is not necessarily more likely, but definitely get more people interested in if there was some Earth-threatening event from like outside. Like, I mean, we wouldn't be able to detect a gamma ray burst. So yeah, if Earth just suddenly disappears in a laser the size of the solar system, yeah, that could happen at any given moment.
If
Or
a
like an
giant,
asteroid.
if squids just started raining down on us out of nowhere, and a giant squid fell on New York, would that do it, Robbie? Do you think?
I think it would unite. I think it would unite at least the Soviet Union and the United States. But I'd be keeping an eye on that Ozymandias guy.
Okay. So
Yeah, okay, reference.
Went
right over my
for
head.
anyone who has read Alan Moore's Watchmen or has watched the recent HBO TV show.
if you
Was
have
it
not
that
watched the
comic? Okay,
TV
yeah,
show,
that's irrelevant. All right.
you should watch the TV show.
So we've talked extensively now about Mars and Venus. They're our neighbors. They're the closest possible choices. If we found something farther, is that farther being in another solar system, something like that? Is that even within people's thought processes
If
when
we
they're
found
in
like
these
a
discussions?
perfect duplicate of Earth, in another solar
But it's
system,
light years away.
yeah,
That kind of
would
thing.
it?
Do we want to go there?
I mean,
Yeah,
assuming we wanted
Assuming
to,
there's
could
reason
we?
to go
okay.
there.
So
yeah.
we want to go there.
Could we?
Yes. Yeah.
Yes, we can get
Would
there.
it be
The
like a
question is-
cryosleep thing or a generation ship?
Oh, you want to send humans there?
Yeah.
Oh.
Yeah, there's a. So
Yeah, that's
right
the
now,
important
we
part.
don't. Right now, we don't have a method of cryoslip. We are not the tardigrade. We cannot remove. Like, if you remove the water from a human, you don't get a dormant human. You get a mummy. And as awesome as like sending mummies to the next planet over
That would be pretty
I
dope.
don't, like,
So
I don't
it
think
would
it
have to be a generation ship then, right?
based on what technology we have currently.
I believe the farthest our cryo technology has gotten so far is freezing people, but not knowing if they can wake up. Is that correct?
Yes, every
Okay.
single person who's
Yeah.
undergone any sort of cryogenic thing is technically dead. Basically, their entire thing is we freeze them with the hopes that sometime in the future we
We
will
can
figure
figure
out
out-
how
yeah.
to unfreeze them. That is the entire process of cryogenics right now.
That's quite a.
It's terrifying.
People just like volunteer for that, or
like for a lot of people, like usually it's the very rich who do this, but I say usually, but there are very few instances of this. But the whole thing is that these are people who either want to wait until the future or should exist, or for example, one potential thing is like if you have some disease that cannot be cured by modern medicine, freeze yourself. Maybe in the future they'll have it fixed.
Legit Nora and Mr. Freeze scenario.
Basically.
So yeah, sending humans is a big.
So if we were to try to do a generation ship, Nick, you mentioned like how big of an issue cosmic radiation would be, even if we put in shielding, either water shielding or lead or whatever. Like, could we make a generation ship that could we make any sort of ship that would be able to withstand light years crossing through open space and taking in all the radiation?
I mean, depending on how long the trip is, sure. If it's like a month and you can somehow accelerate and decelerate enough time to make that trip in a month, sure. Is
that speed achievable?
Theoretically, yes.
Because the thing is, it's space, so you don't have resistance. So theoretically, for something like, I know there's like a solar or sail or something like that, or even
electromagnetic engines.
I mean, if you keep accelerating, you're not going to slow down. You're just going to keep getting faster and faster. Right. Now the question is, can we get up to any reasonable percentage of the speed of light? Currently, probably not now. And even then, we have the equal.
Which we would have to be able to get to another solar system.
Yeah, to get to another solar system, we wouldn't have to do it. We would just have to do it within any reasonable time frame, which is the whole point of a generation ship. The idea is that entire generations of human beings are living and dying on the ship over and over, because that's how long it's going to take for this colony ship to get anywhere.
But yeah, to be realistic, no, I don't think we could build a ship right now that could withstand that travel. Especially if it's to the closest star to Proxima Centauri, that's at least 3.9 million light years, right?
Mm-hmm.
Yeah. So that's a long ass time. Like that's we're not going the speed of light, so it's not going to be.
No, I don't think it's a million light years.
It's just light years.
Yeah, I think it's just light years. So light, it would take if you want to double check how far Proxima Centauri is.
Yeah.
I know it's not millions of light years away.
4.243 light years.
It's just 4.2.
So light, which travels at 3 times 10 to the 8th power.
300 million meters per second.
Meters per second. And so that's the amount of speed you could travel around the circumference of the Earth 7 times in a second. So that something that fast takes 4.5 years to get to Proxima Centauri. We cannot move that fast.
No.
We cannot move anywhere near that fast.
Okay.
So what would have to happen, like we probably were talking about, is an object that is accelerating for forever until it reaches a speed that it needs to start decelerating without killing the things inside.
Yeah.
Because we don't want to crash into it at that percent. Like, even if we got up to that speed, slowing down is equally as difficult a problem.
Mm-hmm.
Huh. Yeah. And you'd also have to keep all the people on the ship from going insane.
Yeah, I have no faith in generational.
Yeah. Now we're talking psychology, which is not either of our things.
Yeah.
Could living things survive that long? I mean, properly radiation shielded, and also because there's a lot of things in space that can try to kill us. For example, we can't go at the speed of light, but there are plenty of particles that are running around it near the speed of light. Just a hydrogen atom crashing into your spaceship at a high percentage of the speed of light is like a hand grenade just hitting your spaceship.
Yeah.
Oof.
And there are a lot of hydrogen atoms out there. Like 98% of all matter in the universe is like hydrogen.
That would suck if you get like
but
90% of the way there,
Robbie?
And then just a random single hydrogen atom.
We'll leave dark matter and dark energy for another episode somewhere later down the line, because that's gonna require a whole other discussion.
That would be like the feels bad of like being a Dark Souls boss, and then some like 6-year-old is playing Dark Souls and beats you, and you're just like sad. You know, it's like that
I
scale.
understand.
Yeah,
Like,
sure.
you're this big ass dope spaceship and you get blown up by a hydrogen atom. Guys, I'm trying to bring pop culture references.
I know, you-
engage
No,
our
yeah.
audience here.
No, like,
Okay.
like I've seen this in like your Dungeons and Dragons style RPG. Like you have this lich who has lived for thousands of years, and then he just gets shanked by Nub Nub the Goblin Bard.
That's it.
Yeah.
Who is not even a player, by the way. Is just the guy. Is just the goblin that you met like 3 floors down in this dungeon and decided to adopt into your group. You gave him armor, you named him Nub Nub, and you gave him the stabby dagger, and you just send Nub Nub at it.
Yeah. All right.
So I think that's a lot to think about. Do we want to, like, we've kind of covered looking forward, like what we want to find out. What do you think we're likely to learn this generation, like within a reasonable time frame, whether that's from the potential life on Venus, whether that's from exploration of Mars, something like that? Is there a major breakthrough we're looking forward to within a reasonable time frame, that kind of thing? I know that's literally a hypothetical that doesn't, there's no way to know what that breakthrough will be, but what is a good goal?
Well, normally I wouldn't have been able to give an answer, but with this Venus thing, if this proves true, like I said, this gives us a whole level of insight with the origin of life, how life can originate, and what might be the origin of life on Earth, or at least the process that led to it. Again, dependent on what we discover here with Venus.
Yeah. And I think in our generation, we're going to be seeing a lot of probing for these signs of life. Like we see with the phosphine, like we see with on Mars with any methane or other metabolic signs of life, as well as with Europa. I'm really excited for Europa and Enceladus, both of which have large bodies of water subsurface, like oceans worth of water. And even just going there and seeing what's there and what's not there, I think will help with the search for life a lot.
So Nick, what are the next steps that they're taking? I saw that there were like at least 2 projects that after these Venus findings were published got fast tracked.
Right.
What are they looking to do to verify in Venus and see what it is? What are they trying to do?
I know that there's a mission that is co-done by the European Space Agency and the Japanese Space Agency that is directing some of its path to do a flyby by Venus and just kind of look and confirm these things. As for
it was already on the way there.
Some more
Right.
spectral
imaging,
spectral analysis. Okay.
As for the ones that are getting fast tracked by NASA, I don't actually recall what they are. I would assume one of them would be some sort of atmospheric analysis, like either a probe that dips through or goes into the atmosphere of Venus would be super cool.
Samples.
Right. In the close future, I could see some sort of atmospheric capture and return being done, which would be really interesting and difficult, but cool.
Remember, Venus still has our gravity level, so it's the issue of having a spacecraft basically fly into something that's Earth gravity, collect something, make it back out, and then make back to Earth.
Right, because the mission that I was on, OSIRIS-REx, it's going to an asteroid, getting a sample and returning it. It's a lot easier to go to an asteroid, get something, and bring it back because you're expending the amount of force that I use to like push on my desk is escape velocity on Bennu. But something like Venus, you need actual rockets.
Well, they have think of all those rocket boosters that you see on a spaceship, or a rocket ship that's flying off. That's the amount of energy we need to get off of Earth. It would be the same to get like.
Would they have to set up like orbital, like a rocket booster ring waiting on Venus?
Like an Apollo
send
mission?
a rocket, yeah.
And
then like once it gets to Venus, it hooks back up to the new rockets and goes in and comes out.
Honestly, yes, I'd say that would probably be one of the better options.
That are a like an atmospheric
That's cool to think about.
That'd be hard to constrain the exit.
And also, would you be able to get? I mean, I know that the phosphine's been located in a high atmosphere, but I'm assuming that's still much lower than it would be.
We can get a really long scoop, just a really long arm with a scoop at the end.
There we go.
Keep in mind that, of course, Venus has a thicker atmosphere than us too, so we have to deal with that increased air resistance as well.
Anything that's going to give definitive proof is going to be bringing it back to Earth, though.
Yeah,
I think.
Yeah, if we find something, this will be
you can do
of our lifetime.
I mean, you could, but there's always going to be arguments against, and to scientifically confirm and prove that it is, you need to have it in a place that you can run the same tests, have other people run the same tests, and have it be as controlled of an environment as possible, which we can make on Earth.
Or even, for example, the International Space Station could
That
be
too.
a go-between. Like, it's a place where theoretically you can have it isolated from Earth conditions and
Yeah.
not have something spread if this is a bacteria-like thing.
Correct. So that's good planetary protection protocol, actually.
There you
Some
go.
PPP.
Recreate the atmospheric conditions on Venus, though, right? To be able to like split the samples up to run multiple tests or whatever.
I mean, the gases of
Or-
Venus, the gases that make up Venus's atmosphere aren't things that we can't replicate ourselves. And like I said, in that upper atmosphere, it is 1 ATM of pressure, so basically the same as ours, and temperature ranges that are within our normal living. So it's just recreating the atmosphere there. That's really the tricky
What
part.
about
Even then,
the?
it's carbon
Wouldn't you
dioxide.
need to recreate the radiation as well?
Venus,
It
even
just,
upper
like-
atmosphere, it's about our levels of radiation. Like that's the thing. Venus's
It-
magnetosphere and
it has-
Venus's atmosphere are both as active as Earth, if not more so in Venus's atmosphere case. Meaning that Venus blocks out as much radiation as Earth. Like we still get solar radiation here on the surface of the Earth. Like Earth's atmosphere doesn't completely block it. Same with Venus.
That's why we get sunburns.
I hate those.
I'm
I
sure
wouldn't
you do,
know.
Andrew. I'm sorry.
I wouldn't know.
One time, it was a long weekend at Schlitterbahn. One time.
Uh-huh. All right, so I think that pretty much covers it. We went down the search for life, 1 hour, laid it all out there. Every fact possible we
You don't need to
covered.
go anywhere else.
That's it.
We
That's
are the empirical source.
Yes.
Honestly, you're
And
welcome.
I expect to see a citation of us in your next paper, Nick.
Or whoever's listening to us. Listener
Yeah,
out
or
there
whoever
who's
listening.
yeah.
If there's any published
We're gonna
authors
get-
like Nick here listening,
I'm a
yeah,
good-
Nick is now a published author, by the way. We'll talk about it later, probably.
shit.
But he's a
Maybe.
published author.
he likes to downplay it, but
I'm gonna get blasted by whoever's like by the people on the mission that are like, Nick, you're not an author.
good. All right, so yeah,
But we can brag about him just fine.
yeah, there you go. So I think that about does it. Any other closing thoughts from y'all?
There should be a lot of people telling us that we're wrong, and I really welcome that, and I would like to hear
Hell
the
yeah.
comments
absolutely.
as well.
I'm
I'm
excited
just
for the
here to
comments
ask
on this one.
questions.
Yeah.
Yell at these two.
Yeah,
Uh-huh.
so I'm really looking forward to any questions or comments or
Like
corrections.
pop culture, yell at Arjo for his wrong opinions. And for science, yell at
My
us for our
opinions are
intuition.
right. You're wrong.
Uh,
Fat and dumb.
But yeah, I do like being corrected as well. So
Absolutely.
that comes out.
All right. So thank you for joining us. If you've stuck through all our episodes so far, and this one in particular, this
Or
has
if you're a
been,
new person.
yeah, or if you're just joining us, this has been the 1D4 podcast. If you have any questions, comments, concerns, hate mail, angry corrections for Robbie and Nick over here, or me, I might have pronounced something wrong. I don't know. Just go ahead and send us an email. It's the 1d4podcast@gmail.com. The link will be in the description as well as on our website to that and all our other social media accounts. So be sure to follow us there for up-to-date information.
Yeah.
So yeah, thanks for listening and see you next time.
Thanks, y'all.
Adios.
I was about to.
All right, we routed. That's
Yeah.
the